Hello and welcome to another test design video. In this video we look at state transition testing. So let us get started. State transition testing is a test design technique. This means that using this technique we can design test cases to give us good coverage of the system testing. State transition testing is based on the theory of finite state machines. So we can use this testing technique whenever we have a system that can be defined in a finite number of states. So first of all, the question is, what is a state? A state is a particular situation or condition in which the system can be. A state has certain attributes or properties and it has a certain behavior. And we'll see examples of different states of different systems in this video. The next question is, what is a transition? A transition is movement from one valid state to another valid state. And this is what we test in state transition testing. So let us see an example. This is the example of a light switch. So we have a light switch which can be used to provide inputs to the lighting system, and the lighting system also has a light. So basically we can switch on the light and the light will be on, and then we can switch off the light using the switch and the light will be off. So here there are only two states in which the system can be. These states are not just for the light but for the entire system consisting of the switch, the electrical circuit and the light itself. So here we can see that there are two states. State 1 is off and state 2 is on. Now if the system is in the off state, we can provide an input. So that input can be turn switch on. So as soon as we provide the input turn switch on, the system goes to state 2, which means the system now is in the on state. So the system has a transition from the off state to the on state, and the output that is generated from this transition is that the light turns on. Similarly, we can have another input when the system is in the on state. We can provide the input by turning the switch off. So when the input is turn the switch off, there is another transition from the on state to the off state, and the output is that the light is turned off. Now let us go a little deeper into state transition testing. So as I mentioned before, state transition testing is used when the system is defined in a finite number of states. So that means if we are able to think of the system as being in one of several different states, we can use state transition testing. So this knowledge can be based on either the use cases that are given for the system requirements or your own knowledge of the system. Now certain inputs to the system under test, the SUT, change the state of the SUT. That means that if a particular input is applied to the SUT, it changes the state of the system from one state to another state, and in addition providing the inputs to the system also produces outputs. So state transition testing involves testing all the valid transitions from one state to another. By valid transitions, I mean that whatever transitions are actually possible for the system to do. For example, in the lighting example that we saw, the valid transition is from off state to the on state and from the on state to the off state. In state transition testing, we can also test the invalid transitions to make sure that they do not occur. So let us see another example, and the diagram that we have over here is for a car. This diagram is also called the state diagram or the state graph or the state chart. So every one of us has driven a car or been in a car that is driven by somebody else. So as you know that the car can be in the stopped state, that means it is stationary or motionless. Then it can be in the accelerating state, that means the speed of the car increases. or it can be in the constant speed state. That means it is moving at a constant velocity of 50 miles an hour or 60 miles an hour. Or it can be in the decelerating state. That means it is braking or it is stopping, or the speed of the car is reducing in that state. So let us look at the state transition diagram here. So we have the stopped state, and these arrows indicate the possible transitions from one state to another state. So from the stopped state, we can just go to the accelerating state. So that means if we push the gas pedal, from the stopped state the car will change into the accelerating state, which means that the speed of the car keeps on increasing. From the accelerating state, it is possible to change to the constant speed state. This means that the car is moving at a constant speed. From the constant speed state, it is possible to make the car in the braking state. That means the speed of the car reduces, and from the braking state the car can change into the stopped state. So this state transition diagram is useful for testing the physical car also, and also a software representation of the car, whether it's in a video game or in any software application. Now here the same information is represented in the form of a state table, and this indicates the valid state transitions. That means the movement of from one valid state to another valid state, and also it indicates the invalid transitions. So let us explore these. So if the current state of the car is stopped, we can provide the input of press the gas pedal more, and then the car will come to the accelerating state. From the accelerating state, if we keep the gas pedal in the constant position, the constant speed state is reached. From the accelerating state, we can go to the braking state by just switching from the gas pedal to the brake pedal. Also from the constant speed state, we can increase the speed of the car by changing to the accelerating state. From the same constant speed state, we can change to the braking state by switching to the brake pedal. From the braking state, we can go to the accelerating state. For example, if you are braking and then you find that the traffic is clear and now you want to increase the speed of the car, you can change from the braking state to the accelerating state. From the braking state, you can go to the constant speed state. That means you were braking earlier, but now you want to maintain a constant speed. And from the braking state, if you keep on braking, then the car will stop. Now there are some invalid transitions also. For example, from the stopped state, it is not at all possible to directly go to the constant speed state, because the car is motionless in the stopped state. So physically it is impossible to just jump from a motionless state to a constant speed state. Also from the stopped state, we cannot have the braking state because the car is motionless, so braking does not make any sense in the stopped car. From the accelerating state, we cannot change to the stopped state. So this means no matter how fast or slow the speed of the car is increasing, we can never stop it by using the gas pedal. Also from the constant speed, we cannot change to the stopped state because this would involve directly jumping from constant speed to a stopped state, and this happens only in the time when there is an accident, when the car stops suddenly. And all this we can derive by looking at the state transition diagram, so which indicates that whatever possible states are there, and using the transition arrows we can figure out that the car can move from which state to which other state. So in state transition testing, we have to design test cases that cover all the valid transitions, so that is positive testing. And we can also design test cases to test that none of the invalid transitions actually take place. So here we have the same state table. So let us say we design a test case 1, and here the workflow is we can change from stopped state to accelerating state to constant speed state to braking state, and braking state to the stopped state. So this covers several valid transitions: stop to accelerating, accelerating to constant speed to braking, and braking to stopped. So since this test case does not cover all the valid transitions, we need other test cases. So we can have a test case 2, and here we can have another workflow. We can move from stopped state to accelerating state, accelerating to braking, braking to accelerating, accelerating to braking, and braking to stopped. Every time you have to look at the state transition diagram to make sure that all the transitions are valid. And with test case 2, we can cover several other valid transitions, for example accelerating to braking and braking to accelerating. Then similarly we can cover the remaining valid transitions. So in test case 3 we can have the workflow as we can put stopped state to accelerating to constant speed to accelerating to constant speed again, then braking, constant speed to braking, and stopped. And this covers the valid transition, constant speed to accelerating and braking to constant speed. Now every time you notice that we are starting with the stopped state. So why is that? Because the stopped state is the start state of the state transition diagram. So everything that has to happen from the stopped state. And this is true when you have to physically test a car. So you are never going to get the car in motion when you start testing it. You will always have it parked, and then you have to bring into motion and test out the acceleration, braking, and working at the constant speed. So stopped state is the start state, and also the final state is always the stopped state, because this is the only final state. You are not going to ever leave a car in motion and then just terminate the test. Always you have to bring the car to a stop, and then only you can finish the test. Another thing here is that it is possible to have a long workflow, and using that workflow you can cover each and every valid state transition. In this particular example, sometimes it is possible and sometimes it is not possible, depending on how the state transition diagram is drawn. So that is about state transition testing. In order to recap, let us remember a few things. A transition is moving from one valid state to another state. And what is a state? A state is a set of specific attributes and behavior. It is a particular situation or condition in which the system can be, and different states are different from the other states. So in this example we can see that the stopped state is very different from the constant speed state, because in the stopped state the car is motionless, it is stationary at a particular place. In the constant speed state it is moving on a path, and it's in motion and has a particular speed. So state transition testing is used when the system is defined in a finite number of states, and in state transition testing we test all the valid transitions. That means all the valid transitions that are given in the use case, or the valid transitions as per our knowledge of the system. And we can also test all the invalid transitions in state transition testing to make sure that they never can take place. So I hope state transition testing is clear to you, and that is all for this video, and see you in the next video. Thank you.